Are you able to hear now?
Yes, 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 baby. It's able to hear now. No problem.
Okay. Okay.
Okay, we will start within 10 minutes, charge baby.
Okay. Sure. Sure. Sure.
Just to close the presentation, we will start.
So, Marish sir, are you able to see my presentation?
Yes, 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 charge. Yes,
Yes,
charge.
sir. Yes, sir.
Okay.
Visible, sir.
Okay. Sure.
It's visible.
Okay. Sure. Sure.
Admissions open. SRM Ishwari Engineering College.
Sir, HOD sir, shall we start, sir? HOD sir?
Yes, sir. If you are ready, we can start, sir.
Yes, ma'am. Ma'am, shall we start?
If you are ready, we can start.
Yes, ma'am. Yes, sir. Good evening to all. A warm welcome to all the participants on behalf of AAA Department, Ishwari Engineering College. We have convened here for the 5th day of International Faculty Development Program on Research Innovations and Emerging Advances in Electrical Engineering. Today, we are going to have a session on subsea power cable installation in oil and gas industries by Mr. George Baby, Operations Engineer, Saipem, Sharjah, UAE. Now, I would like to invite our respected head of the department, Dr. E. Kaliyappan, sir, to share a few words with us.
Thank you, madam. Very good evening and warm welcome to all the members who have joined here on the virtual meet. On behalf of Department of Electrical Electronics Engineering, I take immense pleasure in welcoming Mr. George Baby, Operation Engineer Saipan, Sharjah, UAE, to deliver the lecture on submarine cable installation. Welcome, sir.
Oh, thank you. Thank you.
Thank you, sir. So, first of all, we have to thank him for accepting our invitation to be a part of this 1 week International Faculty Development Program. So, we once again welcome him. And I take immense pleasure in welcoming all the participants who are showing interest as they showed in the first day of this International Faculty Development Program. I see a lot of participants every day attending, and those who have missed, they are also viewing the YouTube, which is made live in the YouTube. So I can see a lot of participants viewing. So I have to appreciate their interest in attending this International Faculty Development Program. Best wishes to the participants. And I would like to appreciate the work, the coordination done by all the 4 coordinators in organizing this 1 week of International Faculty Development Program. So you are doing a wonderful job. So my appreciation and best wishes to all the coordinators also. So with this simple note, I would like to hand over the session. So thank you, best wishes. Have a nice day. Thank you, ma'am.
Thank you, sir. Thank you for a warm welcome. And now I would like to invite Dr. P. Marish Kumar, Associate Professor, AAA Department, to introduce our expert speaker of the session.
Thank you, ma'am. Good evening to one and all present here. I take immense pleasure in introducing our speaker of the session, Mr. George Baby, Operation Engineer, SAIPM, UAE. He completed his MSc Subsea Engineering in University of Aberdeen, UK. He ranked 73rd in the world university rankings. He completed his BE EEE in AKCE, Madurai Kamaraj University, Madurai. He also completed his project management professional course in Project Management Institute, USA. And also he completed his incorporated engineer course in UK. Now currently he is working as an operational engineer in the field of engineering procurement and installation of subsea cables, applicable and flexible pipelines in SAIPM, Middle East. Before that, he worked as a senior method engineer in McDermott, Middle East in the field of engineering procurement and installation of subsea cables, applicable and flexible pipelines. He also have a experience in Siemens, ABB, Hyundai as a testing commission engineer in the field of testing and commissioning of transformers, switchgear, relays, cables in power plant and substations in India and abroad. Thank you, sir. Welcome, sir. Thank you, ma'am.
Oh, thank you.
We are happy to have you, sir. Now I would like to hand over the session to our speaker.
Good afternoon, everyone. Thank you, Marish Kumar sir, for giving this wonderful opportunity to share my knowledge and experience to all the faculty members here available here. And I think self-introduction is not necessary anymore. And Marish Kumar had explained everything about me. And at present, I am working with SAIPM Sharjah, which is an offshore oil and gas construction company based on Italy, Milan, and they have a project around the world. And they are into offshore oil and gas, renewables, onshore oil and gas, drilling, etc., into various sectors. I am into their offshore business unit, taking care of flexibles, cables, umbilical from the engineering point of view, as well as on the installation point of view. Agenda for this meeting is, the presentation is purpose of this subsea cable, the type of cables which we are using on all this industry, then the packaging of this subsea cable, that's meant for why that is important, because that's meant for the transportation and installation. And I will give a couple of methodologies which we use for the installation of the subsea cable. Then apart from the subsea cable, there are other products like umbilical. Umbilical is meant for the power as well as to supply fluids from one point to another point. And the other kind of cables are ICCP, which is the impressed cathodic protection, which mean to protect the offshore steel structures installed in offshore, which is middle of the sea. And the kind of protections which we require for this subsea cable, and the accessories and jewelry which we require to install all these products. And the subsea power cable plays an important role in oil and gas application. And as you are aware, this is responsible for a transmission of electrical power from one point to another. It's maybe, I mean, there are different scenarios, like it is from onshore to offshore, offshore to offshore, and it's from, I mean, like offshore to onshore, which is for the renewables. And all these subsea cables are designed for a lifespan of 25 to 30 years. So all these cables are designed for the fatigue damages which we can occur in subsea due to accident or the environmental factors like the current, tide, tsunamis, cyclones, and all. So, as I explained before, the type of subsea cables are connecting between the platforms, cables connecting between onshore to subsea platform, and windmill, which is from offshore to onshore. So we are here. I have, and I mean, like the layout of one of the projects which we have carried out very recently. And this is from the one we see here. The one is the offshore platform, the one we see in the blue and green, which is on the middle of the sea. And you can say something like 30 to 40 kilometers away from the shore. And all the cables are fed, the power is fed from onshore to offshore. And all these electrical powers are used on this platform for the lighting, operation of all these pumps, equipments. There are several equipment on board on this offshore platform for the mining as well as processing of these oil and gas fluids, as well as gas. So this is an example of the cable which is pulled from onshore to offshore, and the one we see is the rollers which are used to protect the cables while we are pulling on the cable on the ground. And here you can see here the one we see in yellow is the offshore installation vessel, which is a ship. And the cable is fed from offshore, and it's pulled to the onshore. And here you can see there are the vessel is standing like 3-4 kilometers away from the shore, because I mean each ship's got a minimum draft, and they cannot come closer to this. So these fiber optic cables are very important, as you are aware, all these internet and communication. And here you can see these small cables. These are fiber optic cables which are pulled from continental to continental, countries to countries, and the contractors procure all this give order for all these cables and lay cables from continental to continental or countries to countries, which is an really expensive and is a profitable business. And why it is important now, why it is important to discuss with you guys, because so far there are only limited players in India, and we don't have much expertise in India. And this sector is these offshore oil and gas or offshore cables or offshore subsea cable installation. All these jobs are carried out by European or Western companies like Nexen, Saipem, ABB, and there are only few resources from India, and there is a big opportunities on this area for these electrical engineers and mechanical engineers on this area. So this is another, another scenario, which is the cable spread from offshore to onshore, which is for the renewable business. And here you can see all these are it's on a jacket, or it's on a pile, and it's a fixed windmill. As you know, now there is a new technology and new business available. It's a floating business. Floating windmill that is used for deep water renewable business. And in many cases, all this electricity which is made offshore on these windmills are fed to the platforms which is in offshore. And as you know, there are substations to increase the voltage to avoid electrical transmission loss. So this is a life cycle of a submarine power cable, and this is same for fiber optic cables and other product as well. Here you can see the concept study. There we will go through the strategy, from where to where, and what is the requirement, what is the water depth, and what is the voltage requirement, all these power requirement, all these are done here. And then we will go to here, the strategy feasibility. In some places we are not, in some places like a war zone, or there are the seabed profile is not it's like mountains or anything on the seabed, depending upon the seabed profile. And the third one is the environmental impact assessment. In some places we need to do the trenching and all. Trenching in the sense burial. Make a hole and put the cable inside, which is to protect the cable, and we require the permits from the countries, where it's passed through. And here the next phase is the design phase, the basic design, where we will do the electrical, decide the electrical parameters, the power requirement, voltage requirement, and here we need to do the budget as well. And why it is important, for this cable, the cables are expensive, the installation methodology, there are so many equipment, ships are involved. So all these things are performed here, and we need to have a cost estimate. And this is to be approved by the subject parties who is going to invest in this business. And the next phase is the manufacturing of this cable. On this manufacturing cake, on the phase, we consider there will be factory acceptance tests for this cable. Then these are type tests, as you are aware. Then once we complete the manufacturing of this cable, we will do the testing of this cable to make sure the integrity and it's meeting the requirements. And next would be the storage, and it's the cable length. I mean, like there are cases like the cable length is something like 140 kilometer, 150 kilometer, 200 kilometer. Then we need to have a big facility to store these cables in reels or tanks, which we will explain later. Then the transport loadout of these loadout stands for transferring of this cable. We will be doing the transpooling, or are we going to lift this cable, the whole cable, after this manufacturing and transfer to the transportation vessel? That strategy will be deciding and executed here. And the other phase is the installation. Installation is the transportation. Normally, the cables are being made in Japan or Norway, UK, and all these countries. And so far in India, we don't have any, or in Asian countries. There are manufacturing facilities in China and Taiwan. And so far, there is no manufacturing facility in India for offshore submarine cables. And once it's made, we need to transport from the factory to the installation location. That will be done by sea, because that is the easiest and cheapest mode of transportation. So the next one is the construction. The construction, the things which will be carried out in this construction phase is before laying the cable, there will be survey to be done. There are, the cable is going to cross existing cables or pipeline or any other assets, some preparatory work to be done. And the cable will be laid on top of it. And after laying the cable, there will be activities like testing and commissioning. And once we complete the installation and once the cable is powered up, there will be annual or periodic monitoring inspection to make sure the cable is performing and there is no damages, and sometimes some would be cleaning, and all these are necessary. And the last one is the repair. That will happen only when there is a damage to the cable. It may occur due to dropping some objects on it, or someone is accidentally dragging this cable. Some ship drops their anchors and dragging this cable, or maybe due to war or anything. The last one is decommissioning. And since we cannot leave any external assets on the seabed, on the environmental point of view, once the life cycle of the cable will be over, then we need to remove this cable from the seabed. And this will be done by either by cutting into pieces or recovering back to an installation vessel and bringing back to the onshore and disposing it properly or recycling it. So the design criteria for these subsea cables are based on, the factors which are driving this design of a subsea cable is a location. And why location is important? Because in some places like the temperature vary, there will be high Antarctic and all this the temperature vary, and the cable should be designed to withstand those temperature. And when it comes to Middle East or Africa, the temperature will go up to 50 degree, even though most of the part of the cable is below the sea, some part will be on the shore or directly on the sunlight. So the cable will be designed according to the geographical location. Then the water depth. Why the water depth is different? I mean, like sometimes the cable will be laid below 50 meter, below 60 meter, below 200 meter water depth. So when it goes below, to certain level, there will be a negative pressure, and the cable should be able to withstand that. And the other key informations are like to design, the cables, offshore subsea cable is that the type of termination where we are connecting this cable, whether it's to a offshore substation or onshore substation, onshore grid or onshore switchyard or a wind cable, the termination point will be varying and the connectors will be designed accordingly. And the third point is the route length. This will be decided after the engineering phase. Ships will be doing this engineering phase, and there are instruments on the ship which will decide what is the water depth and how is the seabed profile, and the length of the cable will be decided accordingly. And there will be during this the ships or the instrument underneath the vessel or the remote operating vehicle on the ship will do a 3D scanning, and they will take the video. They will take the picture of the seabed, and later on when the information come back to the onshore, we will analyze, and based on that we will decide how to route this cable and how much length we require to connect from one point to another. And as I explained before, the design life of a cable is normally equal to greater than 25, and normally it's the service life of a cable is 20 years. After 20 to 25 years, either we have to recover this cable or periodic inspection is required. The electrical design parameters which drive the design of a submarine power cable is the operating voltage of the system, the lightning over voltage, then the system frequency, whether it's an AC or DC. Now there are DC system is also, like HVDC system is also available. So the AC system, there will be 3-core cable, and in the DC system it's a 1-core single core cable. And the type of earthing used for this cable, as well as the current carrying capacity in case of normal as well as emergency, and emergency in the sense of short circuit. The other driving factor which decides design parameters which drive this design of a subsea power cable is the thermal design rating, which I have explained to you before. The ambient temperature, the change in temperature over the year, the places like Russia and Kazakhstan, the temperature 50 degree to minus 15 to 20 degree. So the cable shall be designed accordingly, and the ambient temperature, the dimension of the reel, that I will come to that later. Then the thermal properties of the cable, the material, then the external heat factors. The last one, the mechanical design parameters, which are to be considered for the design of the cable. For this is for the manufacturing. This is applicable. I mean, all these parameters should be considered based on. I mean, like the manufacturing process, the storage, load out, transportation, and installation. And there are some critical points here, like outer diameter and weight of the cable. Because why weight of the cable is important? Because it should be self-stabilized on the sea bottom. Otherwise, should have enough weight. Otherwise, due to current or due to these environmental factors, the cable may move or drag on the seabed, which will damage the cable. And the mechanical stress properties like crush load, because something fall on the top of the cable, and the MBR stands for minimum bending radius. If you bend the cable beyond the minimum bending radius, the cable will get damaged. So when we get a project to do an subsea cable. So first, the point we should consider is, apart from the electrical properties of the cable, we will decide on the cable route. So when we design a cable route, I mean, like we should consider the terrain. And there will be up and down, there will be rock, there will be, like in so many cases, there will be turtle next, and like a seagrass and all. There are so many marine growth, and during the installation and operation of the cable, these should not impact the marine. So these are the next point is that most of the time we decide design the lay route next to the existing cables or the pipeline, so that we are not making any new crossings or new environmental damage to the system. So this is already done enough protection, and we don't need to damage further. And the proximity of the existing infrastructure, like there are some hazard in the offshore platforms, like some flare, and there are high temperature objects on the offshore platforms, and there are hazards. There are chances to fall something on the seabed, so we avoid those kind of areas. And the other point is the cable protection, which we will discuss later, because I'm explaining in detail. And the cable burial is important, because when we lay the cable on shallow water, like 5 meter, 10 meter water depth, the cable burial is important, because the ships or the tanks or anything passing through that area can damage this cable. So to protect this cable, we make a burial, and we bury the cable 1 meter below the seabed. Even though the ship passed through the area, if the ship ground or drop something, it will not damage the cable. And there are other alternative methods, which are placing the mattress or placing the rock on top of this cable. The tools and equipment used for this subsea cable I will explain in detail, because it's one of the one of the price driven, I mean, like it will make a big cost impact on the project. And there are different type of ships, or we call as a vessel. There are different type of ships are used for the installation of the cable, and we can categorize broadly into two. It's a self-propelled cable lay vessel and the anchored cable lay vessel. Anchored cable lay vessel required, it's not a self-propelled, so we need assistance or the help of other boats to pull these cable, the vessels. And the self-propelled cables are, there are thrusters, engines on it, and it can move while laying the cable. So this is a self-propelled, and if you, I mean, like on the self-propelled cable installation vessel, we can classify further, like equipped with a reel lay. The cable will be wound on these reels, and this will be from the factory or from the port. We reel into the the cable will be reeled into the reel, and the ship will go offshore to the installation location, and it will start laying from one point to another. And in many ships, we can keep multiple reels. Like you can see another here, which is inside. Once they finish this one, they can take the next one and they can continue the cable lay. They don't need to go to the port or the manufacturing facility to take the next cable. So this is an anchored cable lay vessel. This most will be used on shallow water. And shallow water, we can say like 0 to 10 meter water depth. And here you can see there are ropes connected to it. The ropes connected to the anchors, and there are winches. When they pull, the vessel will be moved. And once they finish the rope, they will relocate the anchor to another location using small boats. So there are in subsea, I mean, like we required assistance for connection or visual inspection or anything we need to do underneath. We need to have either underneath the sea, below the sea. I mean, on the sea, I mean, we need either a remote operating vehicle that we see here, or we need divers. The human will go. I mean, like there are gas bottles, or the gas will be fed from the boat, the ship, and this human will go underneath and do the job. And due to, I mean, like on the health and safety point of view, we do avoid deploying divers, and most of the time we use the remote operating vehicle. And the remote operating vehicle can go up to 3,000 meter and do anything, whatever we want. Like either we can take the video, or we can tight the bolt, or if you want to cut anything, they can do it. Anything can be now that the technology has really improved, and we can do like a robot, we can do anything. So as I explained before, we need to bury the cable, trench the cable, because we need to protect on the shallow water, or very close to the platform, or on the war zone. We need to, I mean, there are different methods for the trenching. And here you can see this is a cable cutter. I mean, like this will be like there are sharp teeth on this one, and this will be rotating, and when we deploy this one, this will go to the seabed, and they will cut the sand and bury the cable underneath. So these are different equipment which we are used to bury the cable underneath. And in some cases, I mean, like there are so many cables are laid in parallel, so we don't use the previous method, which is the cutting or burial method. So we use these drenching equipments. Drenching equipments are like what we in India we have the JCB kind of equipment. So this will be attached to the ship, and these will remove the sand and soil like this, and they will make a trench. And the cable will be laid on top of this trench. And after laying the cable, either it will be naturally covered, or we bring some equipment on top of it, and we cover again with soil. There are, I mean, these cables are passing through some existing assets. Like in seabed, we will have pipelines. There will be another cables which was laid before. And this pipeline is used for, I mean, like cross-country transportation of oil and gas. Nowadays, there are hydrogen pipelines. So these, so there are existing pipelines and the cable. And when we need to lay a cable, we need to have a crossings. And here it's a standard design of a power cable. This is taken from a 11 kV cable. And as you know, this the conductor will be always copper, and there will be a conductor screen. Then there will be XLP insulation, and on top of it there will be lead sheet, and on top of there will be anti-corrosion. This is required because we need, as we discussed before, we are laying this cable for a lifespan of 20 years. So these kind of anti-corrosion sheets are required to protect this cable for a long time from corrosion. And apart from the power cable, we always, most of the time, we will have a fiber optic cable. So these the fiber optic cables are meant for the communication. It's like between platform to platform or platform to onshore. Apart from feeding the power, we will deploy a set of fiber optic cable which will be used for the communication purpose. And the last one is the armor. Armor is a steel wire, is a galvanized steel wire, which is meant for to provide the corrosion as well as provide enough weight for the cable and the mechanical protection of the cable. As I explained before, we need to have enough weight of the cable, otherwise the cable will move on the seabed, which will damage the cable, and it will make other issues as well. And these armor serve another purpose, which is the mechanical protection of this cable. Because if you drop something on the cable, I mean, like it can withstand certain force. So this is the cross-sectional view of a 15 kV power fiber optic cable. It's a 3-core cable, and there is a fiber optic core as well. And here, this 15 kV cable, you can see it's a 110 mm. It's like 11 centimeter, how big it is. And this is the weight of the cable in the air, which is this is the 24.6 is the kg per meter. The same is for in the water. As you know, the weight of the cable, any product will be less in water. And there are minimum bending radius. which is quite important because if you bend beyond this minimum bending radius, this will affect the integrity of the cable, and it will lead to fatigue damage. On the beginning of the presentation, I have told you about umbilical cable. Here we can see these are the power cable, power core, and apart from the power core, there are tubings which lead to transport, which meant to transport fluids from one point to another, which is mostly used in oil and gas industry. And these umbilical can be used for the hydrogen transportation as well for the renewables industry. And the third kind of cables which we use in the offshore oil and gas industry is this ICCP cable, impressed cathodic impressed current cathodic protection cable. These are meant for the protection of the offshore steel structures, which are installed in middle of the sea, and this will be act like there will be an anode deployed to the seabed, and the cable will be connecting from this anode to the platform. And these will be acting as an anode, and this will protect the offshore platform, which is a cathode. So now we get into this packing and transportation of this product, because why it is important. I mean, like the weight of the product, I mean, it should be able to handle by the crane or trucks or the transportation vessel. So the packing will be depending upon the installation vessel and the length of the cable, the size of the cable, the weight of the cable, and the installation methodology as well. Here you can see it's coming in a reels. It's a 12-meter reel it is, and the cable or any products are coiled inside this reel, and we transport in onshore. We transport with the trailer, and it goes to the port, and it goes to the destination. And once we reach the next port, and once we reach the next seaport, we'll transfer to the cable lay vessel, and it goes to the installation location and lay the cable. And when it comes to the long cable, like 10 kilometer, 15 kilometer, so that will be transported in a tank. And the weight of the tank will be like a 60 ton, 80 ton. So the transportation is quite easy. And this tank will be transferred to the cable lay vessel, and cable will be laid from these tanks. And here you can see on the end, I mean, like this is the end of the cable. Why it is kept outside? Because it's kept for the testing, access of the testing. This is one of the design of a cable transportation reel, which I have shown the picture before. And ICCP impressed cathodic current protection, which I explained to you before. This is the cable, and this is the anode. And the anode is getting deployed into the seabed, and the cable will be connected to the offshore structure. And before we lay the cable and before we connect to the platform, some preparatory work to be done on the platform. This is offshore oil and gas platform, and some preparatory work to be done on the seabed. Here you can see this is the offshore platform. Here the one we see in the yellow. This is from one of the job which I have done. I mean, it's a 40-meter water depth, and these structures will be positioned on the middle of the sea, 40 to 50 kilometers away from the beach, and the will be extracted from the oil and gas will be extracted from the well, which is located below the seabed. I mean, on the seabed. And there are some, here you can see a small ship which is tied to the platform, and this is to do the preparatory work on the platforms, set up winch and access and some insulation aids to be installed on the platform to pull this cable on the top from the seabed. This is a typical installation storyboard, and so if you want to make a turn on the seabed for the subsea cable, we deploy sandbags, and across the sandbag we make a turn, and this is one of the installation picture which I have, which I am showing here. And here you can see the remote ROV, remote operating vehicle, is there to supervise this deployment of the sandbag. This will be done prior to installation of the cable. And you can see the installation vessel is here. The cable will be fed from the installation vessel. It goes to the platform. Here we call it the J-tube. The cable will be pulled through the J-tube, and the cable will come on the top of the platform. And from here, it will go to some junction box, and from the junction box, it will go to switch gear. So these are the steps. These are the steps, and I mean, the length to be cut on the second end while we lay the cable. I will share the slide later on. I mean, you can go through it, and it's all simple steps, and you will be able to understand. Here, I mean, here the umbilical will be laid. The umbilical, which is meant for the operation of the, I mean, for the operation of the subsea valves. The one end of the cable, one end of the umbilical will be connected to the platform, and second end of the umbilical will be connected to the subsea valves. Here we have a ball valve, and all these umbilicals are used to operate the valves which is on the subsea. And this is for us. I mean, these valves will be middle of the pipeline to stop the flow. I mean, in case of maintenance or for the other purpose. These are the method which I have explained to you. This is the protection of the cable. These will be installed on top of the cable where it is to be protected, and there are bands and which we tighten after installing these half shells. It's like a half shell, and it's a two-piece, and we put it together, and we put the band. We tight the band so that this Uraduct will stay there, and this will be act as a protection, as well as it will provide an additional weight for this cable. And as I explained to you before, when there is a crossing of this cable with existing pipeline, we need to have a minimum distance with the asset, because with the pipeline, because that will cause an eddy current if the cable touches the pipeline. which will cause corrosion for this pipeline. So to avoid all those things, we put a concrete mattress on the top of it, and a cable will be laid on top of it. This is on the preparatory work to be done before we lay the cable. So this is an example. This is a plan view, and you can see the concrete mattress. This is an elevation view. It's the same thing, and this is the pipeline which is crossing an cable. And this job is from a Saudi Aramco projects, which is in Saudi Arabia. And these are the type of crossings. I mean, like a cable will be crossing all these pipelines. And here we have the number of crossings. So when you pull the cable to the platform, this will be through a pipe called a J-tube, and you require some accessories and jewelries to protect this cable. And these are those jewelry or fitting. And this will it called a bend restrictor. This will prevent this cable to bend the cable beyond a certain limit. Obviously, it's a minimum bending radius. So this bend restrictor will protect the cable to avoid any damage to the cable. And obviously, this centralizer, as it meant, I mean, like from the word itself, I mean, like this will help the cable to remain in the center, so that the cable will not touch on the sharp edges of these tube, and it will not get damaged. So once we lay the cable, we need to do some post-lay work, like termination of this cable to the top side, as well as on the seabed we need to install some mattress in case if you need the requirement to do a further stabilization. So here you can see the cable termination. The cable are pulled to the top of the platform, and there is equipment which is used for securing this cable on the top of the J-tube, and from here this will go to the junction box, and from the junction box it will go to switch gear. So these are the two kind of, I mean, like insertion vessel which we converted into cable lay vessels very recently in last 2 years back. These are the specification of the ships, and here these are the equipment we installed on top of the ship. Here you can see the reel, and the one we see in the blue color is the equipment which will help the reel to rotate so that we can lay the cable. And as you know, I mean, like here you can see the crane which will help to do any operation in offshore or lifting these reels onshore. All will be done by this crane. And there are some other equipments on the ship which will help the cable lay to be performed. I mean, like which will help to carry out the cable without any damage. And this is called a chute. This will help the, here you can see the cable. I mean, this will help to maintain the cable, the minimum bending radius. If we don't have this thing, the cable will go beyond a minimum bending radius, which will damage the cable. So in this case, here you can see we have used more than one reel. Once we complete the cable on the first reel, we will remove the first reel and we will transfer the cable to the cable reel to this position, and we will continue the cable lay. The reel is just a drawing which we made for the shifting and transfer of these reel onshore and to the ship. In some cases, the cable will be transpulled from the factory to the installation vessel. That called transpooling. The terminology called transpooling. This is the method here. It's a factory. It's a cable manufacturing facility, and the cable will be fed from here, and it goes to the ship, which is located here, and the cable will be coiled on to the ship. Once the subsea cable to be tested in various phases of the manufacturing, installation, and post installation. That is here. It's from IEC, and the DC on these post loadout on the installation vessel, the DC conductor resistance to be done, the installation resistance, and the OTDR. The OTDR meant for the fiber optic cable. And when on the installation vessel, before laying the cable, these are the tests to be conducted. And once we complete the installation, these are the tests to be conducted on the electrical test as well as fiber optic test, so that to make sure there is we didn't do anything to we didn't damage the cable, to make sure there is no damage to the cable. So so far we were talking about the offshore oil and gas industry. This is the renewable offshore renewables, and here you can see all these are offshore windmills, and the cables. There will be cables connecting between the windmills. Between the windmills, this we called as an array cable, and from the windmill, from the offshore, there will be cable which will be connecting from offshore to onshore, which we call export cable. This is from Murray East platform, which is located in UK, and right now the engineering installation is ongoing. This is from the renewable, offshore renewable, and here you can see the monopile, which will be hammered and pushed to the seabed, and the installation vessel will install this monopile, and due to the weight and when we apply some external pressure, this monopile will go into the seabed and it will remain there. And on top of it, we install a transition piece, and on top of this, the windmill will be coming. And the cable will be laid from this installation vessel through an I-tube, and this cable will be pulled through on top of the transition piece, and it will be connected to the windmill. And this will be going from one windmill to another. And as I explained here before, I mean, like the cable will be connecting between the between the windmills to avoid, I mean, to minimize the use of minimize the length of the cable, as well as yeah, the purpose is to minimize the length of the cable. The purpose of this array cable system. I think I can show one of these. Hello, everyone.
Thank you, sir. Thank you for informative, a wonderful session. Participants can post your questions in the chat box, and also you can unmute yourself and ask the question. There are few questions already posted in the chat box. Shall I read it for you, sir?
Yeah, sure.
The first question is from Sandeep Chaudhary. In addition to the type and routine tests, are there any special tests necessary to be conducted on submarine cables?
Yes, I mean, like on the submarine cable, there are tests. There are tests like the leak test and all to be carried out. I mean, on the submarine cable to make sure the submarine cable will be, I mean, like will be capable to deploy for particular water depth. I mean, there are, apart from the electrical test, there are some other mechanical tests to be done on the submarine cable to make sure the integrity will not be affected. during the lifespan of the submarine cable. So the next question I can see, the next question I can see, I mean, like, what are the challenges are faced during the troubleshooting of this cable? Yeah, the first problem would be, I mean, like, the finding the location. I mean, like, the finding the exact location of the damage. It's not really easy, and even though the existing troubleshooting equipment will give an approximate location, and we will have to deploy either remote operating vehicle or the divers to deploy there, and we need to do the visual check where the damage has been occurred. And some cases we cannot find anything visual, so we will have to, as usual, I mean, like, we will have to cut the cable and see, I mean, like, where it is happened based on the fault locator details, provided details. So it's since the ships and the divers, all these equipments are involved, it's a quite expensive business. In case if there is any damage occurs to the subsea cable, I mean, like, repair is also very expensive, I mean, like, when compared with onshore. And you know, the kit which we will require to splice the cable is different from onshore, because, I mean, like, the after repair of the cable, this will be deployed to water, I mean, like, maybe 50-meter water depth or 60-meter water depth, and that the repair kit should provide a minimum life span of 15 years or 20 years, which the cable is designed for. So altogether it's an expensive thing if this kind of damage occurs. So because of these, I mean, like, when we design a subsea cable, we need to make sure, I mean, like, unless there is any mechanical damage or environmental or accidental damage, I mean, we need to protect from all these factors. I think this is the second question, and what is the output voltage from each wind pole? Okay, there are in UK we have 3.3 kV, and there are 5 kV wind cables as well, from the windmill to these array cables. What about the corrosion problems in cables? Yes. In order to prevent the corrosion, I mean, like, we use galvanized steel armor around the cable, and these anyway, the both sides of the cables are connected, so there won't be, I mean, like, any additional protection is not required in terms of cathodic protection. And if there is any cable damage occurs, as I explained before, we need to locate the cable, the location, and we need to have you need to have a splicing, like a joining of these two cables, and put it back to the sea. It should be a waterproof system. And all these cable manufacturers like ABB, Nexans, Areva, and all, they provide, they have designed a cable splicing system, which is capable for offshore. No, I mean, like this will be installed on. This transformer will be installed on offshore substations, and it will not be installed in these kind of equipments will not be there in windmills. And why these kind of cables are not manufactured in India in any reason? Okay, as you know, I mean, like we don't have much offshore oil and gas industry in India so far. I mean, now we are investing a lot, and I think government is interested to have a lot of, I mean, like investment in offshore oil and gas business. And I think when we have this kind of lot of business, I mean, like I think there will be, I mean, investors or there will be manufacturers will set up this kind of a plant in India as well. We can expect in next 5 years, hopefully. Cable transmission is the best on either fiber optic or wind pole. I mean, we will use the same cable. I have done a splicing for I mean, like damage and further splicing for a 230 voltage cable in Taiwan. And there is there is no reduction if the system, the switch gear, if the entire system is designed for a particular voltage, we cannot reduce it, or we cannot change afterwards. So even though there is a damage, we will do the splicing and we do the repair job. Even after that, the voltage remains the same. Hope there is no further questions.
Yes, sir. Are there any questions? You can also unmute yourself and ask if there are any further questions. If not, we will wind up with the session. I would now like to call upon Dr. P. Marish Kumar, Associate Professor, to share vote of thanks with us.
Thank you, ma'am. It's my privilege to propose a vote of thanks on this occasion on behalf of Department of Electrical and Electronic Engineering, Ishwari Engineering College. I take this opportunity to extend our most sincere thanks to our guest speaker, Mr. Charge Baby, Senior Methods Engineer, SAIPM, Sharjah, UAE. I would like to thank our respected Chairman Sir, Vice Chairman Sir for his vision and who always encourages us in organizing such programs. My heartfelt thanks to our Principal Sir, Vice Principal Sir, and the HODs of various departments. I thank our beloved HOD Sir, Triple Department for their guidance and motivation. Last but not least, I thank all the participants who have joined with us for our International Faculty Development Program. Thank you all.
Thank you all. The feedback link is posted in the chat box. I request all of you to fill the feedback link. Thank you, George Baby Sir, for joining with us and giving us a wonderful session.
Thank you, Charge Baby Sir. Thank you.
Thank you, Marish Kumar Sir, and everyone for giving this opportunity to talk and share my experience and knowledge. Thank you, everyone.
Thank you.
Thank you, all participants. You can fill the feedback form, which is posted in the chat box, and join with us tomorrow at 4 o'clock for a session on renewable hydrogen energy system for island and microgrid by Dr. M.D. Alamgir, postdoc Research Fellow, Queensland Micro and Nanotechnology Centre, Australia. Marisa, please post the feedback link in the YouTube also.
Yes, ma'am.
I posted, ma'am.
Poster.
Hari Prasad, can you post it in the from the channel? The one which Lydia ma'am has posted is not. I think it's not posted. Hari Prasad. Just post the feedback link in the YouTube. The feedback link for the YouTube is also available in the description box. For the participants who have joined us through YouTube, the feedback link is available in the chat box and also it is available in the description box. It is also available in the description.